Hello everybody, it's Miss Stover. Today we're going to be talking about atomic structure. So today in class we talked about subatomic particles, and I actually tried to get you to bring me to an understanding of what you already understood. And for the most part, most of you understood everything that was in this particular table. We understood that the particles that make up an atom are electrons, protons, and neutrons. We also understood that the charge of an electron was -1 and protons were +1 and neutrons were 0. Some of you got to mass, but remember, this will be discussed a little bit later on. I'm giving it to you here today just to make sure that you understand. These numbers right here in parentheses are actually the mass in grams. The numbers on top, an AMU, are atomic mass units, and we'll be talking about both of those a little bit later in discussing what that means. The location is important as well. Electrons are not found in the nucleus. They're found outside the nucleus in an electron cloud, and then protons and neutrons are found inside the nucleus. And so that makes a huge difference about what we talk about here. So today, we know that atoms are composed of identical protons, neutrons, and electrons. And we also talked about today the fact that how do we know the difference between one element and another element, an atom of one element and an atom of another element? And the answer is the number of protons. The number of protons help us to identify the substance. And so therefore, we know that the protons help us to know which atom it is, because the atomic number, symbolized by the letter Z, of an element is equal to the number of protons found in that element. We also realize, because atoms are neutral, that protons are equal to electrons. And remember, we talked about the fact that we do not want to say the atomic number is equal to electrons, but we do say that the atomic number is equal to protons, and then protons are equal to electrons in an atom. So we need to make sure that we keep those things straight so that misconception doesn't happen later on. So then the atomic number, just to show you a little more information, we know that we can see from this table, we have some information about the atomic number. Carbon has an atomic number of 6, which means the number of protons in carbon are 6. Phosphorus has an atomic number of 15, you're right. And so the number of protons is 15. Gold has an atomic number of 79, which means gold has 79 protons. So we can see pretty clearly that there's a relationship between atomic number and number of protons. So then we go to mass number. Now mass number, we have to be sure that we understand. Mass number is actually an equation. We get to use this as an equation. We can say that mass number is equal to protons plus neutrons. So we can write an equation from that information, so that when we see this particular table, we can then begin to decode how many protons, neutrons, and electrons, and also the mass number from the information given. Now the word nuclide is just a fancy name for the word atom. This is just describing a specific atom of an element. So here we understand that we have the atom oxygen. That gives us a piece of information that's very important here. So oxygen has an atomic number of 8, which means that we would have 8 protons. Because we have 8 protons, we then have 8 electrons. Now, to find the mass number here, we simply take protons plus neutrons, and we get a mass number of 8 plus 10, which is 18. Now that number, notice, is a whole number. This is what I want you to recognize. If you look on the periodic table, you'll find a mass, an atomic mass for oxygen of 15.99 or 16.0. That is not the number 18. So the number on the periodic table is not always the mass number. That number is an average, and that can give you the most common atom of oxygen, but it does not give you all the atoms of oxygen. So when we're naming this oxygen atom over here, we have to include the mass number to specify what that atom of oxygen is. So we use the mass number to do that. Now, notice here, the next one, we have 33 protons. That tells us that the atomic number is 33, which means we have an element called arsenic. So that gives us some information. Because we have 33 protons, we know we are going to have how many electrons? Yeah, that's right, 33. So what are we going to do to get the mass number over here? How are we going to get that? Well, if we add 33 plus 42, we get a mass number of 75. There we go, we have a mass number of 75. So Because we have a mass number of 75, that means this particular nuclide, this particular atom is called arsenic 75. Exactly. So let's use some of that information. So we see this 31 here. This 31 tells us that we have a mass number of 31 in this particular atom. Now we go to the protons. We have 15 protons. What does that tell us? It tells us the atomic number. The atomic number means that this is an atom of phosphorus. So now we can decode the rest. Because we have 15 protons, we're going to have 15 electrons. Now what do we do to figure out the number of neutrons here? We'll go back to the equation. Mass number is equal to protons plus neutrons. So to get neutrons by themselves, we have to subtract protons from both sides. So if we do that, 31 minus 15 will give us 16 neutrons. So we see that that works pretty well. So next, we're going to talk a little bit about complete symbols. Now, we've seen one way to look at a nuclide. We've seen this way to look at a nuclide right here. Writing it out, writing the name and the atomic or the mass number out. So we can use that as a way to identify different atoms. But we can use another way. That's called the complete symbol. The complete symbol contains the symbol of the element, the mass number, and the atomic number. So if we look at it, there's the symbol of the element. X represents a generic symbol. So there's the symbol. It's nice and big and bold. Whatever the element's symbol is goes right there in the place of the X. If it's a two-letter, you'd have two letters, one capital and one lowercase. Then the atomic number is used as a subscript, and the mass number is used as a superscript. Literally, the subscript is below and the superscript is above, exactly what it says. So let's see if we can decode some information from something like this. So here we go. We have the element bromine 8035. We see those numbers. So we know right away what this number is and what this number is. We already know what that means. And since we have Br, we know what that is as well, because Br is the atomic or the symbol for bromine. So let's see if we can decode. Number of protons. Well, protons equal the atomic numbers. The atomic number is 35, so we have 35 protons. The number of neutrons. Well, remember, mass number is equal to protons plus neutrons. So I have to subtract to get the number of neutrons. So if I take 80 minus 35, I get 45. So I have 45 neutrons. The number of electrons, well, that's the same as the number of protons. So I have 35 protons. Next, the atomic number. Well, we already know that. It was given right there as the subscripted information, 35. And the mass number is given as the superscripted information, 80. So pretty simple to identify all of these numbers. So let's try one more. If an element has an atomic number of 34 and a mass number of 78, what is the number of protons? Well, we have the atomic number right there. The atomic number is 34. That means we have 34 protons. The number of neutrons, remember, mass number is equal to protons plus neutrons. So if I subtract mass number minus protons, I get neutrons. So I take 78 minus 34, and I get that I have 44 neutrons. 44 neutrons. The number of electrons, remember, equals the protons, so that's 34 electrons. Now the complete symbol. We have to be able to write that complete symbol. So all we have to do is go back to the information that we need. We need the atomic number, we need the mass number, and we need the symbol. So we have the atomic number, that's 34. That goes right there. The mass number is 78. So now we need to decode what is the atomic number of 34. The atomic number of 34 stands for selenium. Selenium's symbol is Se. So there is the complete symbol for selenium, for that particular atom of selenium. So let's try another one. If an element has 91 protons and 140 neutrons, what is the atomic number? What is the atomic number? So let's look at that. So we see very clearly that we have 91 protons. So the atomic number is equal to the number of protons. So we have 91. Oops, sorry about that. Don't know what's going on. So let's see, 91. Wow, Miss Stover's having a little trouble here. So we have, let's try this again. We have 91 as the atomic number. The mass number, now the mass number is equal to protons plus neutrons. So that would be 140 neutrons plus 91 protons would give us 231 is the mass number. Number of electrons is equal to the number of protons. We were given that in the problem, so we have 91 electrons. The complete symbol? Well, we have 91 is the atomic number. That goes on the bottom. 231 is the mass number, and it goes on the top. So what is the atomic number 91? And that goes with protactinium. Pa is the symbol for that. Okay, we have one more example here. One more example. Let's try it. So if an element has 78 electrons and 117 neutrons, what is the atomic number? Well, we've got all this information, so let's start with what we have. We have 78 electrons, and we know that electrons are equal to the number of protons, so we can answer C best first. We have 78 protons. Once we know the number of protons, now we can go to the atomic number. The atomic number would also be 78. Now is the mass number. Remember, mass number is equal to protons plus neutrons. There are 78 protons. There's 117 neutrons. 78 plus 117 is 195. What is the complete symbol? Once again, what is the atomic number? The atomic number is 78. What is the mass number? The mass number is 195. So what atomic number is the element 78 for? And that is platinum. That is Pt. So here we go. This is your little journey into determining protons, neutrons, and electrons, also known as the pin number.